Hi, I'm Bob with Purdue MEP. Before we jump into our first module, it's important to know that this playbook guide was developed using 3 real-life new technology deployments with small manufacturers as examples to illustrate the concepts and steps of this playbook. Let's take a look at the case studies of these 3 companies. Our first case study involves the deployment of collaborative robots, or cobots, at Centurian Arms, a machine shop in Indiana that manufactures firearms, parts, and accessories. The company had more demand for some of their products than they were able to manufacture with their available labor force. So the owner wanted to retrofit their facility with machine tending automation for longer production runs. Cobots were a good option for their facility, as the cobots are designed with safety features that make it easier for them to operate in close proximity to people. The company had 2 CNC milling machines that were targeted for the automated machine tending. After discussing the opportunity with automation experts, they determined that the machines could be potentially operated 24 hours a day with machine tending cobots, 3 times longer than the 1 8-hour shift they were currently running. The company owner selected a local cobot vendor and systems integrator to design and install the new system. The team identified several performance requirements. For example, the CNC machines needed to be modified with a new auto door system to enable the cobots to automatically open and shut the CNC door to load and unload parts. The cobots needed not only to be able to open and shut the CNC door, but also be able to press the start button on the CNC machine and remove lubrication fluid from the parts after the machining process was finished. To achieve these requirements, the integrator ordered a new auto door system compatible with the CNC machines and the cobots. They also designed and 3D printed custom grippers for the cobots tailored to fit the parts being loaded and unloaded, and added a special tip on the grippers for pressing the CNC start button. The end of the cobot arm was outfitted with a compressed air nozzle for blowing off liquid from the parts post-machining. To ensure accurate positioning for the cobots, holes were drilled into the shop floor in front of the CNC machines, and anchor bolts were used to secure the cobot pedestal to the floor. A part presentation table was designed and installed to allow the queuing of enough parts to accommodate a 24-hour production cycle. The cobot pulls an unmilled part from the table, and when the milling process is complete, places the finished part back into its original spot on the table. The cobot control system was wired into the CNC machine controls to allow operation of the newly installed auto door system, and compressed air was connected to the cobot for the blowdown nozzle. An area safety scanner was installed to automatically slow the cobot speed or stop it completely depending on how close a person is to the cobot. To help the operations team know where the slow and stop zones are, colored tape was laid down on the floor to show the boundaries of those zones. Once the programming and testing of the cobot was complete, operators were trained on how to use the cobot, such as how to run the program, how to manually move the cobot arm, and how to restart the cobot if it stops due to an error. The installation process took about 5 days, but the results were excellent. The cobots were able to successfully operate unsupervised for 24 hours, which tripled the company's production capacity from running just 1 8-hour shift prior to the project. Some of the key lessons learned during the project include recognizing the need for planning extra time for unexpected issues during deployment. Fine-tuning the cobot programming took longer than expected due to challenges in removing parts from the collets, which required waiting on new collets to be ordered and installed before the installation process could be completed. Another lesson learned was how to involve operators in the design process. Operators had valuable insights on design considerations for the cobot work cell to make it easier for them to access the CNC machine for tool changes and maintenance, how to configure safety zones to reduce unnecessary slowing or stopping of the cobot, and how to effectively remove lubrication fluid from the milled parts. Another key takeaway was the importance of carefully selecting a suitable technology solution provider. The company had previously tried to deploy a cobot at their facility several years before, only to be disappointed by the system performance when the installer was done. The poorly designed system created headaches and production issues for months afterwards. The operations team was therefore justifiably doubtful that these new cobots would work, and they were pleasantly surprised by how well the cobots performed when the project was completed.